Assalamu alaikum and welcome to Mathcast with Faria Yusuf. And this is going to be the chapter differentiation and the second topic, which is the chain rule. So, chain rule means differentiating a function of a function. So, differentiating a function of a function means if I give you an equation, let's say that this equation is y is equals to square root of 4 minus 3x. So, what I can see here is that within the square root I have two terms. I have more than one term, and in this case I have two terms. So this means that this function is basically the function of a function, the first function being the square root, and then it's the function within the function itself, which is 4 minus 3x. So that means here the differentiation should be taking place in two steps. It should be taking place in two steps. How? Let's see. It's y, which is equals to 4 minus 3x, and this is whole to the power 1 by 2. So this differentiation shall be taking place with respect to the outer power, which is a 1 by 2, and then we shall be differentiating the function, which is 4 minus 3x. Meaning, if I start with the differentiation of 1 by 2, then I should know that in this case, it's going to be the dy by dx, which shall be equal to a 1 by 2. Obviously, this 1 by 2 gets multiplied by the coefficient of the bracket, which is a 1 in this case. So it's 1 by 2 times 1, giving me a 1. And then I should say it's a 4 minus 3x and 1 by 2 to the power negative 1. And after that, I should be differentiating the function, which is 4 minus 3x. So we have seen that first we have differentiated this y with respect to x with respect to the outer power 1 by 2. And in the next step, I will be differentiating the function within this power, which was a 4 minus 3x. So therefore, I'm saying that it should be done in two steps here. So here now I can say that my differential dy by dx is going to be a 1 by 2, 4 minus 3x to the power negative 1 by 2. And then in this case, it's going to be the differential of 4 being a constant. It gets eliminated. And then for minus 3x, my differential shall only be a negative 3. So further, I can say that my differential equation dy by dx shall be equal to a negative 3 by 2, and then 4 minus 3x, I'm taking it to the denominator so that the power becomes a positive. So this becomes square root of 4 minus 3x, and then this is going to be the answer to this question here, or the differential or the derivative of the given y equation. Let's do another example so that the concept gets more clear. Dy by dx in each case. Part A, it's y, which is equals to x squared plus 4 to the power 5. So here I can see that I have x squared plus 4 more than a term. There are two terms here, and then we have the outer power, which is a 5. So first I should be differentiating it with the outer power so that this becomes dy by dx, which is equals to, obviously the outer power gets multiplied by 5, and here I will be left with x squared plus 4 and 5 to the 5 minus 1. Obviously, for differentiation, I know I have to subtract a 1, therefore 5 minus 1 gives me a 4. And the second step, I should be differentiating the function within the bracket, which is x squared plus 4. So in this case, my dy by dx by the chain rule becomes 5 times x squared plus 4 to the power 4, and then here I can say x squared differential is going to be 2x, and then 4 gets eliminated. So my differential equation here becomes a 10x x squared plus 4 to the power 4. So this is how I will be differentiating this given equation of y in terms of x. Let's do another question. Part B, it's y, which is equals to 5 over 6 cube root of 4x minus 3. So again, it's a composite equation. Cube root 4x minus 3, meaning 4x minus 3 more than 1 terms is to the power 1 by 3. So to do the differentiation, first let's rearrange the y equation in a simpler form so that I can say it's 5 by 6 into 1 over cube root of 4x minus 3. We know cube root means it is to the power 1 by 3. Therefore, here I can say it is a y which is equals to a 5 by 6, and then it's 4x minus 3. I'm taking it to the numerator, and then because I'm taking it to the numerator, the index changes, the sign of the index changes, and this becomes 4x minus 3 to the power negative 1 by 3. We know that if I have a cube root of y, then this means it's y to the power 1 by 3. Or if it is the cube root of any value a, nth root of any value a, then this is to a to the power 1 by n. So after that, now I can start doing the differentiation. I can say it's dy by dx. 5 by 6 is the coefficient of the function, so it will remain a 5 by 6 and gets multiplied by the power, which is a 1 by 3. And then I can say it's 4x minus 3 and negative 1 by 3 and a minus 1 here. I am done with the differential of the index of the outer power. So now I should be differentiating the function within the power, which is 4x minus 3. So now it's the second step that should be followed over here. So solving that, it should be a 5 by 6 times negative 1 by 3, or else I could have written this as a negative 5 divided by 18, and 4x minus 3 to the power negative 4 by 3. And then here I can say it's just a 4. The differential of 4x is a 4. Negative 3 being a constant gets eliminated. Further, I can simplify the equation. I can say it's 2 twos are and then 2 nines are, and then 5 times 2 gives me a 10. So my final equation for this differential or the derivative equation here becomes dy by dx, which is a negative 10 by 9, and making this power positive, I can say it's a negative 10 by 9, 4x minus 3 to the power 4 by 3. And this is going to be the final answer or the derivative of the given y equation here. So now we are given the equation y equals 6 divided by 2x squared plus 3x. So again, I can see I have variables in the denominator and I need to differentiate them. I need to get the derivative of the function. Therefore, to simply derivate this function, I should say it's y, which is equals to 6, and it's 2x squared plus 3x to the power minus 1. Now start doing the derivative, start getting the differential of y with respect to x. This 6 gets multiplied by the negative 1. Here I will be left with 2x squared plus 3x and negative 1 and a negative 1. And in the second step, I shall be differentiating the function inside the bracket, which is 2x squared plus 3x. So dy by dx here now means it should be a negative 6 and 2x squared plus 3x to the power minus 2, and then here I should be having the differential of 2x squared. So that means it should be a 2 times 2 giving me a 4x, the power reduced by 1, 2 minus 1 gives me an x, and then in this case for the differential of 3x I will only be left with a 3 here. So final answer to this question is going to be a negative 6 times 4x plus 3 divided by, bringing it to the positive index form, I should say it's 2x squared plus 3x, and this is whole to the power squared. So this is going to be the answer to this question here. Differentiate each expression with respect to x. Part A, it's 2 divided by the fourth root of 5 plus 3x. Now again, it's a composite function. And for this composite function, I can simply say that this can be expressed as 2 divided by 5 plus 3x, and this is to the power 1 by 4. Meaning I can take this to the numerator saying it's 2 times 5 plus 3x, and this power becomes a negative 1 by 4 here. So I need to differentiate the function. So I can say it's d by dx of this function. So to do that, obviously I will be having here 2 times negative 1 by 4, and then it should be 5 plus 3x, and for this it should be a negative 1 by 4 and a negative 1. And in the second step now, I should be differentiating the function, which is a 5 plus 3x. So over here, this 2 and 4, I can very easily simplify them, and I can say it's a negative 1 by 2, and then it's a 5 plus 3x to the power negative 5 by 4, and then differentiating the function 5 plus 3x, 5 gets eliminated, and for 3x I'll be left only with the 3. Therefore here I can say that my differential is a negative 3 by 2 and 5 plus 3x to the power 5 by 4. So this is then going to be the answer to this question. Part B, you have been given the equation 1 divided by x times 5 minus 3x squared. So here I can see that we have two functions which are getting multiplied by each other. Therefore, I can simply expand the equation, and if I do that, I will be left here with 1 divided by 5x minus 3x cubed. After doing that, simply I can say that this function can also be written as 5x minus 3x cubed to the power minus 1. So here again I can see a composite function. There are two terms in x, and they are both with respect to the power, which is a minus 1, meaning if I differentiate this function, which is 5x minus 3x, and this is 3x cubed, the whole to the power minus 1, then first I shall be differentiating it with respect to the minus 1, the outer power, so that here I can say it's a minus 1, and 5x minus 3x cubed, this is to minus 1 and minus 1, and then I should be differentiating the function which is within the bracket, which is in this case is 5x minus 3x cubed. So finally, I should be having a negative 1, 5x minus 3x cubed to the power minus 2, and then here I can say the differential of 5x is a 5, and differential of negative 3x cubed. The 3 here gets multiplied by 3, giving me a 9. So it's a minus 9, and x to the power 3 minus 1 giving me a 2. So finally, I can say that this function here is negative 5 minus 9x squared divided by, I can take the negative 2 function to the denominator so that the power becomes a positive square. So further I can say that the answer is a 9x square minus 5 divided by 5x minus 3x cubed, the whole square, and this is then going to be the answer to this question. Now we need to differentiate 1 divided by 1 plus square root of x. So 1 plus root of x, again in the denominator I have two terms, and both of them being in the denominator, when I take them to the numerator, this becomes 1 plus root of x and whole to the power minus 1. So I can see that there are more than a term within the bracket which has a power which is a negative 1 here. So this becomes a composite function, and for the derivative I should be following the chain rule here. So to follow the chain rule, that means I should be differentiating this 1 plus x to the power 1 by 2 and the whole to the power minus 1. So firstly, I should be differentiating it with respect to the negative 1. I can see that the coefficient of the bracket here is a 1. Therefore, 1 times negative 1 gives me a negative 1, and here I shall be left with 1 plus x to the power 1 by 2, and this is negative 1 and a negative 1, and then I will be having the differential of 1 plus x to the power 1 by 2 here. So in this case now I can say it's negative 1, 1 plus x to the power 1 by 2, which is a negative 2, and then the differential of the function constant 1 for differentiation gets eliminated, and then for x to the power 1 by 2 I should say it's the coefficient here, which is a 1, gets multiplied by a 1 by 2, giving us a 1 by 2, and then for x I should be having a 1 by 2 and a minus 1. So in this case I can see that I am having negative 1 divided by 1 plus square root of x to the power 2, and then it's a 1 by 2, and x to the power 1 by 2 minus 1, which shall be having a negative 1 by 2 here. So writing it in a proper form, I can say that this answer is a negative 1 divided by 2 root of x and 1 plus square root of x the whole square. So this is then going to be the answer to this given equation, which so this negative 1 divided by 2 root of x times 1 plus root of x the whole square is going to be the answer for 1 divided by 1 plus root of x here. So this is how these questions for differentiation shall get solved for simple differentiation, and then we can have the chain rule method here. So these are the two methods of differentiation which shall then get applied to the word problems for finding the equations of tangents and normals, or their maximum or minimum points, or the stationary points, which we shall be covering in the next video. So best wishes, and see you all in the next video then.